Okay, this is still section 3.3. We'll finish up this bit of information here. So on page 157, problem 50, we have a function and determine the quadratic function's graph is given. Okay, so our vertex is at 2, 1, and the y-intercept is at 0, 5. Well, it's easiest if I write the function in the form f of x equals a times x minus h squared plus k. The vertex is at 2, 1. So f of x equals a times x minus 2 squared plus 1 is what I've got. F of 0 is equal to 5, since 0, 5 is on the graph, which means that 5 is equal to a times the quantity 0 minus 2 squared plus 1. 0 minus 2 squared, negative 2 squared is 4a plus 1. Subtract 4, 4 equals 4a divided by 4, a is equal to 1. Okay, so a is equal to 1 means that f of x is equal to x minus 2 squared plus 1. Problem 58. Determine without graphing whether the given function, the given quadratic function has a max or min value, and then find the value. So here's problem 58. F of x equals 4x squared minus 8x plus 3. Okay, well, we can know right away that the function is going to have a min value because the a value is positive. And so the vertex is what we need to compute. Negative b over 2a, negative b over 2a, 8 over 8 is 1, and then f of 1 gives me 4 minus 8 is negative 4 plus 3 is negative 1. Okay, f of 1 equals negative 1, so negative 1 would be the answer. Okay, problem 76. The graph of a function f of x equals ax squared plus bx plus c has a vertex at the point 1, 4 and passes through the point negative 1, 8. Find a, b, and c. Okay. So I've got the information written again. It passes through this point, negative 1, negative 8. I'm going to begin by writing the answer in this vertex form, since I know the vertex. Okay, the vertex is at 1, 4. So f of x equals a times x minus 1 squared plus 4 means that passes through negative 1, 8, negative 8. F of negative 1 equals negative 8. Okay, and so negative 8 is the y value, negative 1 is the x value, and I can find a times 4 plus 4, subtract 4 from both sides, negative 12 equals 4a, divided by 4, a is equal to negative 3. So the function that we're talking about is negative 3 times x minus 1 squared plus 4. Well, I just write it in the form ax squared plus bx plus c. Means I simplify. So negative 3x squared plus 6x minus 3 plus 4. Negative 3 plus 4 is negative 1. So it's positive 1. Negative 3x squared plus 6x plus 1 is the answer. Okay, problem 90 is we're going to be maximizing revenue. The John Deere company has found that the revenue in dollars from sales of riding mowers is a function of the unit price P in dollars that it charges. If the revenue, R of P, is equal to negative 1/2 P squared plus 1900 P, what is the unit price P that should be charged to maximize the revenue, and what is the maximum revenue? Okay. Maximize is a key word. And so I just simply find the vertex. I know I've got a parabola that opens down. Okay. And so finding the vertex means that I would be maximizing the revenue. RP is the revenue. Negative B divided by 2A. That's negative 1900 divided by negative 1 is 1900. And then R of 1900 gives me 1,805,000. So the unit price should be $1,900, and the maximum revenue charged is $1,805,000. Okay, so this is just simply an exercise in finding the vertex. Problem 92 is given here. Let's see here. See problem 91. Okay. The marginal cost, C, in dollars of manufacturing X cell phones in thousands is given by this function. How many cell phones should be maximized in order to minimize the marginal cost, and what is the minimum marginal cost? Okay. Minimize is a key word. Minimize means I'm going to be working with a parabola that's opening up, and I want to find the minimum value. So I just find the vertex. Negative B over 2A, or 200 over 10. 200 over 10 is 20. C of 20 gives me 2,000. C is 20. Okay, so the marginal cost in dollars in X cell phones in thousands is given by this function. Okay, so I get 20,000 cell phones is the minimum cost, or the number of cell phones that should be manufactured in order to minimize the cost. And then what is the minimum cost? It's going to be $2,000. Okay, so this is just a situation where you're finding the vertex is the problem. Okay, so the problems there are on page 156. Try out problems 13 through 91, the evens, or the odds, okay, we'll stop right there.